Well, so due to lack of memory constant, I have to stop suddenly in the last video. So the next and the last problem what we are going to discuss in continuation of the numerical related to this DC machine is the last one, that is given that we are having a 250 volt decision motor that would be drawing some current 5 ampere under no load condition, and what is given that the armature resistance is 0.2 ohm and the field resistance is 100 ohm. Under no load condition it will be drawing 5 ampere of current and its running would be at 1200 rpm. Now when we would be applying some load, so obviously the current would be going to get increased and that would become 50 ampere and the flux becoming the 0.95 times of the actual flux due to armature reaction. The brush voltage is given. So let's see what is going to happen, how we are going to solve it. So since this Vs would be the voltage across this, so ISH will be what? This should be Vs by RTH, so that would be coming to be 2.5 ampere. Now under no load condition, so let us case 1, no load. Under no load condition, the total current IL is equal to 5 ampere. So what is going to happen? This armature current under no load will be equal to 5 minus 2.5, because IL will be equal to IA plus ISH. It would be 5 minus 2.5, that will be equal to 2.5 ampere. That would be the no load armature current. And what is also given, that the flux phi under no load condition, that we can assume it to be equal to phi. Now under this no load condition, the back EMF EBNL, that would be nothing but Vs minus IANL into RA minus the brush voltage drop. So Vs is already given, that would be equal to 250 minus 2.5 will be the current into RA will be 0.2 into brush voltage drop. That would become, how many number of brushes are there? 1, 2. Each brush is equal to 1 volt, so it becoming 2 into 1, that is equal to 2. So the total back EMF would be coming to be 247.5 volt. This should be the no load back EMF. Now the case 2, loaded condition. So what is going to happen? Now the IL is becoming 50 ampere. So what would be happening to the armature current under loaded condition? That would be 50 minus 2.5, because the shunt field current is going to remain same, because the armature resistance is going to remain same. So the current will be armature current would be 47.5 ampere and the flux under load condition will be 0.95 times of the actual flux, because there is a reduction of flux by 5% due to armature reaction. So the phi L will be 0.95 into phi. So if that is the case, now we are going to trying to find out the back EMF under loaded condition. That would be coming 250 minus 47.5 into 0.2 minus 2 into 1. So that is coming to be, if you are going to calculate it, it will be 238.5 volt. So we are finding out the back EMF, we are finding out the flux. Now what we know, N is proportional to EB by phi. So therefore what we could write there, that speed under loaded condition by speed under no load condition can be given as EBL by phi L into phi NL by EB/NL. So we are knowing all the values. We have to find out NL. So that would be coming what? This thing into NL. So if we are going to solve the thing, it is coming to be 121722 RPM. Now in the MCQ, I share the MCQ there. Of that, the most closest value of that was 1220 RPM. That is the most closest value of this one. So that would be the correct answer. If there is no MCQ, if it's a direct problem, so alternatively what you could write it, it is equal to, approximately equal to 1217 RPM you may take, because if you could round off, so you could write this one. So this answer will also be appropriate. But since in MCQ the most closest answer is this one, so this one will be the appropriate answer. So that is how basically you need to solve the problem related to this DC machine. If you have any query related to the concept that how we are going to have it, you could ask it from me without any hesitation. So I'm stopping here. Hopefully the video would be useful for you. Thank you. Have a nice day.